Students, now we see the topic electrochemistry session 7. Before watching this video, you subscribe the channel, press the bell button, and also I gave the link in description. Press it. Okay, thank you. Now the learning objective of this session is electrolytic cell and electrolysis. Next, electrolysis of molten sodium chloride. Next, Faraday's law, Faraday's first law and Faraday's second law. Okay, now one by one we will see that. Okay, now electrolytic cell and electrolysis. The definition of electrolysis. The definition of electrolysis. This is very important 2-mark question. Electrolysis is a process in which the electrical energy is used to cause a non-spontaneous chemical reactions. This is the condition, very important 1-mark question. Electrolysis is the non-spontaneous chemical reaction because the energy is used to decompose the compound into its elements. If any compound taking in electrolysis process, it decomposes to anion and cation. That is the electrolysis process. This is the non-spontaneous process. The electrical energy is used because the energy is supplied from the external source. Okay, now next, the device is used to carry out the electrolysis called electrolytic cell. Which equipment used for electrolysis? That electrolysis, that process of electrolysis is carried through the electrolytic cell. Electrolytic cell. Now, the electrochemical process occurring in the electrolytic cell and galvanic cell are the reverse of each other. The two cells, electrolytic cell and galvanic cell, they are opposite one. Okay. Let us understand the function of electrolytic cell by considering the electrolysis of molten sodium chloride. This is the example for electrolytic cell. We take the molten sodium chloride for the electrolyte. You know very well, sodium chloride is a good electrolyte in water content. Okay. Now we see the cell. Now electrolysis of molten sodium chloride. The electrolytic cell consists of 2 ion electrodes dipped in molten sodium chloride. See this picture. The ion electrode 1 and 2. The 2 ion electrodes, steel electrodes, are dipped into the molten sodium chloride. They are connected external DC power supply. DC power supply means from the switchboard. Okay. The key is shown in the figure. The key is already mentioned. Okay. This is the electrode for the steel dipped in the molten sodium chloride. You see the diagram. Next. Next, the electrode which is attached to the negative end of the power supply is called cathode. We already know that in cells there are 2 electrodes, one is positive and another one is negative, one is anode and another one is cathode. The electrode negative is attached to the power supply, that is cathode, and one which attached to positive, this anode. Positive means anode. Okay, you know very well. Next, once the key is closed, the external DC power supply drives the electron to the cathode, at the same time pull the electrons from anode. This is the process in electrolysis. The electrons movement from anode to cathode, electron movement from anode to cathode through the external DC power supply. This is the electrolysis basis. Okay. Now cell reaction. What are the cell reactions? The molten sodium chloride, the sodium ions are attached towards cathode, where they combine with electrons and reduce to liquid sodium. In cathode reaction, reduction is taking place. Reduction means gain of electron. Cathode reduction is taking place, gain of electron. Sodium plus is molten condition. Molten condition accept the electron, one electron from Cl minus. Cl minus release the already anode. In anode, oxidation takes place. Chlorine ion minus ion is releases the 2 electron. So this 2 electron accepted by sodium, and they neutral sodium liquid is obtained. Okay. In anode, the chlorine ion releases the 2 electrons. This is the oxidation process. Loss of electron is oxidation. Gain of electron is reduction. Okay. The E cell value E0 is equal to minus, that is reduction. Reduction means minus 2.71. This is also oxidation. Oxidation value minus 1.36 volt. This is given by the experimental value. Now the overall reaction, sodium liquid plus Cl. The two reaction subtract, add the two equations. These two equations are addition of two equations, sodium plus, and the electron is cancel it. The 2Na plus, okay, 2Na plus and 2Cl minus is gives 2Na plus Cl2. I will write in manually. In this reaction, 2Na plus 2 electron, cathode 2Na plus 2 electron minus gives 2Na. Anode 2Cl minus releases 2 electron. Cancel it, 2 electron cancel it. 2Na plus 2Cl minus gives 2Na plus Cl2. This is the overall reaction for this. Okay. Now the negative E0 value shows the above reaction is non-spontaneous one. Negative value, this is the it shows the negative value 4.07 volt. This is a non-spontaneous one. E0 is negative means delta G is equal to positive. Delta G value positive in thermodynamics, the reaction is non-spontaneous. So the power supply of voltage greater than 4.07 cause the electrolysis of molten sodium chloride. So above the 4.07 voltage current, the electrolysis of molten sodium chloride carried. Okay. This is the condition for this electrolysis of molten sodium chloride. The electrolytic cell, oxidation occurs at the anode and reduction occurs at the cathode as in a galvanic cell, but the sign of electrodes reverse. Already see this topic, already told that the galvanic cell and electrolytic cell is a reverse one. So the sign same, oxidation occurs in anode, reduction occurs in cathode, but the sign of electrolytic cathode is negative and anode is positive in galvanic cell. So this is the condition. Okay. The image of the two cells, one is electrolysis and then another one is galvanic cell. Okay. The electrolysis, the battery is connected through the two electrodes. The one is anode and another one is cathode. In anode, negative ion is absorbed. In cathode, positive ions are absorbed. Okay. In same galvanic cell, reverse sign, the anode is negative and cathode is positive. This is the condition in galvanic. Okay. Next, Faraday's law of electrolysis. Faraday's law of electrolysis. This is very, very important 5-mark question in this chapter. They fluently asking this question. Okay. Now, first law. The mass of the substance liberated at the electrode during electrolysis is directly proportional to the quantity of charge passed through the cell. How many charge of current passed through the electrode is directly proportional to the mass of the substance liberated or deposited, anyone. This is the first law. Okay. The mass of the substance liberated at the electrode, any electrode, positive or negative, the electrolysis is directly proportional to the charge passed through the cell. How many charge? Q is passed through the cell. This is the first law. Okay. M directly proportional to Q. Therefore, the charge is related to the current by the equation Q is equal to IT. Already lower classes we see that I is equal to Q divided by T. I is current, T is the time, Q is the already the charge. Therefore, Q is equal to IT. Q is equal to IT. Current and time. Multiplication of current into time. Okay. Now, therefore, mass is directly proportional to IT. Q mass is proportional to Q, the charge. Therefore, mass is directly proportional to multiplication of current into time. Or M is equal to ZIT. Here Z is the one term is introduced. This is the electrochemical equivalent. The electrochemical equivalent of the substance produced of the electrode. This is the Z. This is very, very important concept in problem. Problem is so many problems are there in book bag. So, the Z is very, very important. Z is the electrochemical equivalent. Now, the condition, write the condition, current is 1 ampere, time is 1 second, the Q is 1 coulomb. In such cases, M is equal to Z. When the Z is equal to M means all are unity, that is I is equal to 1 ampere, time is equal to 1 second, Q is equal to 1 coulomb. In this condition, M is equal to Z. The electrochemical equivalent is defined as, this is a very, very important 2-mark question, very, very important for NEET and JEE also. The substance deposited or liberated at the electrode by the charge 1 coulomb. 1 coulomb equivalent, this is called electrochemical equivalent. This is the Z. Z is called is equal to M. That is the substance liberated or deposited at the electrode by 1 coulomb current passed through the electrodes. Okay. This is the condition, very, very important. Next, electrochemical equivalent and molar mass. The relations between electrochemical equivalent and molar mass. M N plus ion, M N plus ion aqueous solution and Ne minus a number of electrons released gives metal solid. M N plus ion aqueous, this is the general equation, redox equation. We infer from the equation n moles of electrons required to precipitate 1 mole of M N plus as M, the deposited ion from ion to metal, that is gain of electron. Gain of electron means reduction taking place. The number of moles required to precipitate 1 mole of M N plus 2 M metal ion, neutral ion. The quantity charge required is equal to charge of n moles of electron, that is equal to n Faraday. This is very important relationship. The quantity charge required to precipitate 1 mole of Mn plus. This is the ion, cation. Quantity of charge required. How many charge required is equal to charge of n moles of electrons. How many electrons released? That is called Nf. In other words, the electrochemical equivalent of Mn plus, that is Z of Mn plus is equal to molar mass of M, molar mass of metal ion divided by metal atom, molar mass of metal atom divided by N. N is the number of electron released, that is the concept. 96,500, this is the 1 coulomb value, 1 coulomb value. So this is, or another one formula is there. Z is also this formula or this formula, equivalent mass divided by 96. The molar mass of metal ion divided by N is the equivalent mass, is equal to equivalent mass. Molar mass of metal ion, metal atom divided by N is equivalent mass divided by 96,500. The two formula is there. One is molar mass and another one is equivalent mass. Next, second law of Faraday. When the same quantity of the charge passed through the solution of different electrolytes, the amount of substances liberated at the respective electrodes are directly proportional to their electrochemical equivalents. For example, there are so many electrodes are connected with each other, separate cells. The total quantity of charge passed through the solution of different electrolytes. Different electrolytes means sodium chloride, ammonium chloride, or some metal chlorides. The different electrolytes, the amount of substances liberated or deposited any one. The substances liberated or respective electrodes directly proportional to the electrochemical equivalents. Electrochemical equivalent. The 3 electrolytic cells inside the book, the 3 electrodes, 3 electrolytic cells. The DC electrical source connected with each other, and the cell filled with different electrolytes. One is nickel sulfate and copper sulfate and cobalt sulfate. In diagram, nickel sulfate first, second one is copper sulfate and another one is cobalt sulfate. They are connected with external source, DC electrical source. The Q coulomb is passed through the combined formation. The combined form, the first cell, second cell and third cell are connected each other with one source, that is one battery. The coulomb, Q coulomb passed through the electrolysis. The mass of nickel, copper, cobalt deposited respective electrodes, Mni, M copper and M cobalt. M nickel, M cobalt, copper and M cobalt. Mass of nickel, mass of copper and mass of cobalt. According to second law, mass of nickel is directly, already see the relations in first law. Mass is directly proportional to Z. Therefore, mass of nickel is directly proportional to Zni, that is electrochemical equivalent. The Z is the electrochemical equivalent. Next, M copper is directly proportional to Z copper, M cobalt directly proportional to Z cobalt, or M Ni divided by Z Ni, that is M divided by Z, M divided by Z copper, M divided by Z cobalt. This is the relationship of the Faraday's second law. Very important question. First law and second law, important 5-mark question. Very important. Don't forget it. You note it. Very important question. The the same quantity of the electricity passes through the solutions of different electrolytes. Different electrolytes all are through one connection. 3 electrodes electrolytic cells are connected in one source. That is, the amount of substances liberated at the each electrode are directly proportional to. Here nickel is deposited, here copper is deposited, here cobalt is silver. In this example, copper, silver and nickel, the 3 separate cells, each one is deposited, copper deposited, silver deposited, nickel deposited. All are directly proportional to their chemical equivalent. So the final conclusion of second law. This is the conclusion of second law. Next, I will explain the one problem in your book inside example problem. Okay. Now, example problem inside the book example. Yeah, solution of silver nitrate in electrolysis for 20 minutes with a current of 2 amperes. In this problem, time is given 20 minutes and current is given 2 ampere. The solution of silver nitrate electrolysis carried and silver deposited in cathode. So what is the mass of deposited the silver? Okay, we calculate it. Now given solution, I is equal to 2 ampere, T is equal to 20 minutes, in minutes converted to seconds, therefore 1200 seconds. The chemical equation at cathode occurs, the silver is deposited. So silver plus ion plus accept 1 electron from anode. This is the 1 electron from anode gives silver. Addition or gain of electron is reduction. So mass is equal to ZIT. This is the relationship of Faraday's law. Mass is equal to ZIT. In IT is equal to 2 ampere into 1200 second is equal to 2400 coulomb. So IT is equal to this is. Okay, now Z, I want Z concept. Z is the electrochemical equivalent is equal to molar mass of silver divided by 1 Faraday is equal to molar mass of silver is 108. This is fixed value, general value. Molar mass of silver is 108 divided by 96,500. So therefore mass of silver deposited M is equal to 108 divided by 96,000 coulomb into 24,000 2400 coulomb. So cancel it, coulomb cancel, and then 108 into 24 divided by 965. This is the value 2592 divided by 965. Again divide 2592 divided by 965. The answer is 2.68 gram. So the silver deposited, the mass of silver deposited in cathode is 2.68 gram. This is the final conclusion for this inner example. Thank you for the watching this video. After that you subscribe this channel. Okay, I provide the link in description. Okay, now thank you.